So let's work through a few more of these log examples. So this one looks like a bit of a mess. First thing though, if you remember, when we have a common base, we could just add the exponents. So I could rewrite this as E1 minus 3x plus 5x. So then that's going to give us E1 1 plus 2x. And over here, it'll just be equal to 2e and 2e. Now, of course, the exponent on the e here, what's implied is a 1. So I can divide this by e, and I can divide both sides by e, so let me do that. Now, again, we have a shortcut here. When you divide, it's like subtracting the exponent. So I could rewrite this as e to the 1 plus 2x minus the 1. So now I have e raised to the power of 2x is equal to 2. At this point, we have two choices. One is we could take the log of both sides, or we could convert into the exponential form. I'm going to convert this into the exponential form. So my base here, my base is e. So it's the same as saying the natural log of 2 is equal to the exponent, which is 2x. So again, let me just so my base goes there. The exponent will go on to the other side of my equation, and then the 2 will go just like that. So now if I go and take the natural log of 2 and divide it by 2, and I find that x is equal to 0.3465. And something nice to do on a problem as messy as this is we could actually plug this answer right here. Take this answer, you plug it right back in. I'm just going to do part of that for you. We could go then over here to check. We could actually go E1 minus 3 times that 0.3465, kind of ugly, times e to the 5 times that number, and see if it's equal to 2 times e. So that's how you would check it. Let's move on down now to another example. So first we'll start off with some of the easier algebra. We'll add 4 to both sides. So now we have 3 times 1.4 raised to the power of x equals 64. And of course you can see we can divide both sides by 3. That leaves us 1.4 raised to the power of x equals to kind of a messy number, 21.33, repeating. Now at this point we have two choices. We could take the log of both sides, or we can convert it into the log format. And in this case, our base here is it's doable, but it's kind of messy. So I think it's best in this case to go ahead and take the log of both sides. Or you could take the natural log of both sides. It would work out just as well. So I'm going to take the log of both sides, which then allows me to bring that x out front. So now I'm going to have x times the log of 1.4 is equal to the log of 21.3, repeating. And now you can see we can go ahead and divide by the log of 1.4 and divide by the log of 1.4. Now just a couple points here. One is you could do these here separately, but it's going to be better if you put it in your calculator this way. Remember both parentheses. So if you enter it in directly in your calculator as one piece, you have less rounding error. and that'll give us 9.0951. And again, this is something that's very checkable. So there's our answer, but again, we could just plug it back in. So a check would look like 3 times 1.4 raised to the power of 9.0951 minus 4, and that should give us our 60. All right, moving on to another problem. We are currently in the log format, so let's rewrite this one in the exponential form. To try to do the base change here when we have a bunch of variables, it's not going to make things any easier for us. So we're going to convert to exponential format. So now we're going to have 5 raised to the power of 3 equals 8 minus 3x. So we have 125. And now I'm going to subtract the 8 from both sides. So negative 3x on the right side, and then we have 117 on this side. And divide by the negative 3. X equals negative 39. And let's try another one here. This looks pretty intimidating, but it actually works out pretty well. So if you go back to, here we have a subtraction sign, which is the same as divide. So I can rewrite this as a single log. This is log of 5 plus 4x divided by 3 plus x is equal to the natural log of 3. Now, I want to clarify something here. We are not doing this. This is not the natural log of 5 plus 4x, natural log of 3 plus x. Okay? This is not what we're doing here. This is a single log. In fact, if you wanted, I could write in the parentheses like that. Now, since we only have a single term on each side, we can ignore the logs. Essentially, what we're doing now is we really just have 5 plus 4x divided by 3 plus x equals 3. So now just some basic algebra. To get rid of that, I'm going to multiply both sides by 3 plus x, 3 plus x, and I'll need to distribute that. Over here on the left side, those just go away. Now that gives me 5 plus 4x equals 9 plus 3x. And I can, let's get rid of the 5 here. And let's get rid of the 3x on both sides. So that goes away, and I'm left with x equals negative 4. So that one works out quite nicely. Now this one, notice we have a log here, but there's no log on the right side. So we're going to combine the equations like we did before. So I have log base 2 of, and then that is the same as, let me erase that there a little bit. The plus becomes the same as multiplication. So we have x minus 7 times x. And I think just to clarify that a little bit, I'll put an extra set of parentheses around it, and that's equal to 3. So probably the best thing to do now is convert this into, we're currently in log form, is to rewrite it in exponential form. So my base is 2, my exponent is 3, that's going to be equal to x minus 7 times x. So let's go ahead and distribute the x right there. And the 2 to the third becomes an 8. So I have x squared minus 7x. And it looks like we're going to move in towards a problem that requires a little bit of factoring. So let's subtract the 8 from both sides. So we have